Okay, so it says, graph the rectangular solid that contains the ordered triple, triple meaning that it's got an x, a y, and a z, and the origin. So we're talking about with respect to the origin and with respect to this point. So if A is at -3, 1, 2, let me graph that. This is my x value, this is my y value, and this is my z value. Okay? So let's start at the origin, and I'm going to go in the direction of x, -3. Now remember I told you coming towards you is positive. Going back is negative. So if I'm going to go back, -3, right there. Then I need to go 1 unit on the y-axis. Well, the y-axis is right here in front of me. See that? But I'm up here, so I need to go to the right, and I'm going to kind of try and draw parallel with this line right here. See how I'm doing that? And I'm going to go over 1 unit, and I'm going to guess that's about right there. But I'm not done. My z coordinate is 2. Z runs north and south, right? So I have to go up 2. So I'm going to be looking at my z coordinate right here, my z-axis, and say, okay, I'm going to go up 1, 2. And my point is out in the middle of space. Okay? Imagine that you're right here at the origin, and A just floated out into space out there. Okay? All right. Now I think it's easier, instead of me trying to go through each one of these vertices, if I start at the axes. So let's start at x. How far, because we're talking about a rectangular solid. They only gave us 1 point. Well, actually, they gave us 2. They told us we're going to start at the origin, and let's see, solid that contains the ordered triple. It contains that one. Well, if it contains that, can you imagine you've got a figure here? It's a rectangular figure. Well, rectangular figures have opposite sides are congruent, right? Right? So I'm going to have a bunch of edges, correct? But the edges are in space. So let's try and create the edges and see if we can start seeing what this figure looks like. So I know that one of my edges has to start here, right? Because the origin's part of the figure. The origin's basically the corner of it, right? So which one do you want to envision first? Do you want to envision how tall it is? Do you want to envision how wide it is? Or how deep it is? Doesn't really matter. How wide it is. Okay, so which one of these represents how wide my figure is?
The Y.
The Y. So the Y says it's 1 wide. So it's 1 wide. Okay? Which one do you want to do next?
Height.
Height? How high is it? 2. So it's up 2. Okay? Can somebody already see the face of it?
Yeah.
It's right there. Right? Because if it's that high, doesn't it have to be that high on this side too?
Yeah.
So isn't this right here
The
face of it? It is indeed. All right? This face that's a vertex of the figure out in space. All right, what do you want to look at next? The X. So that's how deep the figure is. How deep is the figure? It's -3. 1, 2, 3. So that's where it stops, right there. Look. So it stops right there. Let me do it one more time. There we go. Right there. So if it goes that deep, then doesn't this side also have to go that deep as well?
Yeah. Oh.
You see that? And doesn't it have to close right there too? It's not perfect, I realize that. Let's not overanalyze it, or you know me. I'll fix it. Now what? What do you think this point is? It's the top corner right there, right? See it?
Oh my gosh.
And it also has to have a top on that side, right there.
And then it comes over.
And then it comes down. And then it's got to come to the front. And it's got to come to the front.
Oh my god.
See how we did that? There's only, I mean, notice, your homework is not that much. I really cut your homework down. I want you to attempt to be able to draw these, but I realize that they're difficult, okay? So, but it takes practice. You can't just walk, I mean, I practiced it 3 times. I practiced it last night. Then I got up this morning because I finally, my eyes hurt and I couldn't do it any longer. So I practiced it this morning, and then I practiced it when I did it in first period, and that didn't go very well. And now I'm practicing it again, and I think I did it pretty good. This was so much better than first.
Really good.
Okay.
So if you give me the 1 point, you plot the 1 point.
And then you start thinking about, you plot the 1 point, and then you start thinking about your vertexes. And you would start with your axes, right?
If you do like a whole solid with only 1 point, you need at least 2 points to start it.
Well, you need at least 2 points to start it. You need the origin. Okay, so this is what theirs looks like. Mine looks pretty good. Thank you for being so positive, Pedro. Okay, this is the part you're going to need for your test tomorrow. Okay? Your quiz, I'm sorry. Which is not that big of a deal. Determine the distance between F and G in coordinate space. So these are 2 points in the middle of space, and we're trying to find the distance between them. Distance formula. Isn't the distance formula the change in x, and the change in y, and the change in z? So all I really need to do is find, let's call this one x1, y1, z1, and the lovely part of the distance formula is, does it matter if they're negative? Nope. x2, y2, z2. The only thing I really need to do is figure out which one I want to start with. I'm going to start with F. So if I go from F to G, how far did I move on my X?
Well, it doesn't matter
It doesn't matter if it's positive or negative. You guys, you know what, just because it's the first slide, let me go ahead and do it formally. To go from 4 to -2. Now envision that on the x-axis. To go from 4 to 0 is 4 already. And then to go to -2 is 2 more. So that's 6. But let's do it formally. To go from 4 to -2 is 6 squared. Right? Do y. To go from 0 to 3. Right? Doesn't matter. It's the change is 3. And to go from z
1
to this z would be going from 0 to 1, which doesn't really matter because it's just a distance of 1. So we've got 36 plus 9 plus 1. So 36 plus 10 is 46, which is about how much?
6.8.
That's probably a pretty good 6.8. I think actually, and 6.8. That's what I have. Good job. Let's look at our steps. Our steps were distance formula in space, which the only difference between distance formula in space and distance formula in a coordinate plane is just an extra number, an extra coordinate, right? Your z-coordinate. Substitute, simplify. Determine the midpoint. How do you find midpoint? What does mid mean? The middle. How do you find the middle of something? It's the average. Right?
Oh, yeah.
So, since we're adding, doesn't really matter, right? So 4 and -2 divided by 2 0 and 3 divided by 2, and 0 and negative 1 divided by 2. Makes 1, comma, 3 halves, comma, negative 1 half. Midpoint formula, substitution, simplify.
For this one, do you have to actually use x1 in the right spot, or can you put x plus x?
Nope, doesn't really matter. That's what I did. I combined them, right? I did 4 and negative 2 makes 2. 0 and 3, 0 and negative 1. Okay? Okay. Here is the big one. Reflect the right triangular prism in the XZ plane. Graph the image under the reflection. The XZ plane, okay. Promise no laughing, right? Let's do this. So if this is the X axis and this is the Z axis, can you see that I have a plane right, let's see here. There? Kinda? Sorta? Is that better?
What?
A little bit better? Let's color it. Let's fill it in with red and make it a little bit transparent. You see it? Yeah? It's a wall. It's a wall in the XZ plane. Okay, it's like a shield. Right, James? It's a shield. We are going to take this figure and we are going to reflect it. Now, normally when we reflect over a line, normally we just go right over it, right? But this isn't a line. This is a wall. So we're going to actually have to pick up this figure and physically put it on this side. Okay? Everybody understand? So we're not flipping it over the wall. We're picking it up, we're carrying it over, and we're turning it and putting it on this side of the wall. Let's do it. Now this is where it's easy. X, Y, Z. If I'm just reflecting over X, what stays the same? X. So what do you think stays the same when I reflect over XZ? X and Z. So every single one of these coordinates that's an X or a Z is going to stay the same. The only thing that's going to go different is the Y, which makes sense because this is the Y-axis right here, right?
Yeah.
So if this is the Y-axis and I pick this up and I put it on the other side, aren't I just putting everything in the same place except for I'm shifting it on this side of the Y? So let's do that. So I'm going to take, and every single one of these is going to be the same. 0, comma, what's the middle one going to turn to? 1, 0. This one's going to be 3, comma, 1, 2. 3, comma, 0. 3, comma, 3, comma, 1, 2. On your quiz, that's all you're really going to need to know, is how would it look on the other side with the coordinates, not graph this big old figure and then put it on the other side. I realize that that's pretty hard to do. Okay, so I'm going to go ahead and do this. I'm going to try, because this is hard. Okay, so A prime. If A prime is right here, then A prime has to be on the other side. That one's not that hard. I can tell it's right there. 0, 1, 0. 0, 1, 0. Perfect. That one's done. 3, 1, 2. Okay, here's B. This one's going to be harder. Let's just do this. Let's do this plane right here first. That one's going to be hard. Because once I can see it, it's easier to draw stuff after you can see where it's going, right? If I try and take this and put it, and honestly, it's not going to be over here. Where's it going to be? It's going to be on the other side, because if you pick this thing up and turn it around, it's going to be on the other side, and that's going to be hard to draw. So let's stick with these right here. if F is here, then wouldn't F just be right over here? No, it's going to be on the other side. But I can still graph it. Yeah, let's start with E. E is going to be at 3, 1, 2. So I'm going to go 3, which is 1, 2, 3, then over 1, and then up 2, up 1, 2. Okay, I'm trying, guys. That's E prime. You want another color?
Yeah, turquoise. Turquoise. Like red, and a different color like red.
Okay, what about
Turquoise. Nice.
do this one? Okay. Okay. So 0, 1, 0 is right there. 3, 1, 2. 3, 1, 1, 2. Okay. Now what? D?
Yeah.
D is going to be 3, 1, 0. 1, 2, 3. Over 1 and 0. Now what? This one? F. 0, 1, 2, 0, over 1, up 2. Okay. I'm getting there. We need a blue, the straight line. Okay, so let's draw it. I can see it too. All right, let's keep going. What do you want me to do next? C? 3, 5, 0. 1, 2, 3. Out 5. Holy cow. 1, 2, 3, 4, 5.
Yeah.
Okay, I can see that. Then what? B? Is that the last one? Okay, so B is at 3, 1, 0. No. 3, 1, 2. So 1, 2, 3. That's right. 3, 1. We already did this.
Not 3, 1, 2.
3, 1, 2? Yeah, it's right here. Something's wrong with these numbers. Something has to be wrong with these numbers. What is this one? This is 1, 2, 3, 4, negative 5. B is, that doesn't say negative 5.
No, that's big because it comes 3 and then it goes over negative 5.
Okay, but look it doesn't say negative 5, it says negative 1.
Let's just change it.
So Y has to be 5.
So the numbers are messed
The numbers messed up. So, guys, I didn't know. I didn't get this far. Oh. Yeah, it's the book. It's the example in the book. Okay, guys. Okay. So let's make it our own. If this goes here, then don't I have another one that is the same size? So I could just copy the other one, right? And then it would go like this. And then it would go like this. And like this. Like this. Yay!
Yeah, it looks beautiful too. The color stands out very nicely.
Determine which coordinates will stay the same. We did that, the x's and the z's. Apply the translation formula means apply that negative. Plot the vertices, graph the image. Okay, guys. Now I'm going to give you your notes. So hold on one second.